Hello and welcome.
Hi.
Another month, another Rust meetup, right, Stefan?
Right, absolutely.
Absolutely. I hope you are enjoying a beautiful evening. We are broadcasting here from beautiful Linz in Austria, and the weather is so awesome. We have blue skies, we have sun is shining. It's a beautiful spring evening. So, the perfect day for a Rust meetup, right?
Absolutely.
Absolutely. Did you already play with your kids outside today, Stefan?
Yeah, sure. So I try not to stay outside too much because it's also the weeks of the flying pollen, and
Yeah.
and they kind of spoil spring a little bit. But I enjoyed it nonetheless. So I took a little break this afternoon, went outside, played around with my kids. They are now at their auntie. So I have a free evening. That's
Mhm.
new. Didn't expect
Ah,
that, but
yeah.
I'm looking forward to this evening.
Absolutely, absolutely. So I think we should get started by our
Mhm.
round of community news as usual, right? I will share my screen. I've prepared some slides that we can use to notify you from interesting events that are happening in the Linz IT community. So this is our 20th meetup. We have 4 meetups left until our second birthday. Stefan, I think we need to organize a big birthday party with such a great cake as we had it last year, shouldn't we?
With more cake, even more cake.
With
It was
more
fantastic.
exactly, exactly.
So for everybody who wasn't there the last time, I guess I'm going to post this image again on social media. We had a
Absolutely.
Ferris cake, which
Yeah,
was just fantastic. It was chocolate cake in a Ferris coating. If you want to have one yourself, be sure to be there at the next anniversary. It now has to be cake. It's only
absolutely.
possible with cake.
Yeah.
So
It happened one time, so now it's a tradition, so it has to okay, let's get going with the community news. As you all know, probably by now, the Rust Meetup is brought to you by the Coding Club Linz. And yeah, today's speakers, we have two awesome guest speakers. Miguel and Wedson will be here, and they are going to talk about Rust for Linux status and wishlist. This is a very interesting topic, and I'm really very much looking forward to this talk. And then we have two speakers who are already here. Stefan and I will do a brief introduction into WAGI, the WebAssembly Gateway Interface. You know, Stefan, when I took a look at WAGI, felt really old because I know what CGI is, I know what the Common Gateway Interface is, and it was a real, back again, back to the future,
I,
something like this.
I remember all the crimes that I did back then, 20 years ago, or even more, 25 years ago. So
Exactly.
it's fantastic. I got
And
so
we
many
will,
good memories back, but also so many niceties. There's so many subtleties that we are going to encounter where this entire principle makes a lot of sense. So this is a very impromptu talk. We just spoke about over the weekend. That we want to do this together because I had some slides from back then and Rainer created some examples. Revisiting the entire thing was a joy. So I'm really looking forward to this one.
absolutely. But the main highlight will be definitely Rust
Oh
for
yeah.
Linux. And we are
Oh
very
yeah.
much looking forward to that. And we want to say thank you to Miguel and Wetson for taking the time to be with us. So, if you want to join the discussion, join our Discord server. Maybe, Stefan, you have the time. Maybe you can copy the link into the YouTube chat so that
On
people don't
it.
need to write it down. Um, some community news. As always, our very own Coder Dojo Linz, the programming club for kids here in Linz between 8 and 17 years, will happen as always, as every Friday afternoon. Tomorrow afternoon, I think we have tomorrow 8 hours of workshops for beginners, for semi-professionals. Everything is there. So if you have kids, or maybe you have grandchildren, or nieces and nephews, or whoever is between 8 and 17 who would like to learn how to code, feel free to send them the link. The only prerequisite you need is you need to understand German, because we are here in Linz and we will do the coding club for kids in German. The female coders, our friends at Female Coders, will do their next study group at the 6th of April. So if you are a woman or a girl who is in IT, in coding, or if you want to enter coding and you want to find some like-minded women and girls, take a look at their study groups. And they are also coming up with a bigger event in autumn. We will tell you more about that in the upcoming Rust events. Our very own Global Azure, we will do a cloud computing oriented event on the 6th of May. You can find all the details at globalazure.at. It will be a virtual conference. You can join from wherever you are. And the call for contributions is currently open. So, do you want to have Rust content there? We definitely should. So, take the opportunity, and maybe you have a great talk that you would like to propose there. The next meetup that we would like to draw some attention to is the Cloud Native meetup. I looked it up. They have their next meetup, I think, in a week, approximately March
Mhm.
teeth. And please note, they are no longer on meetup.com. They are now on cncf.io. Here is the link. So if you want to get notified and if you want to look up what the topic will be, please take a look at this link.
Also,
Okay.
it will be an in-person meetup
Oh yeah, it
this
will
time.
be
Yeah.
an in-person meet. Thank you for pointing that out, Stefan. It will be an in-person meetup. So if you want to have something new after a lot of virtual meetups, come and visit the Cloud Native Computing Meetup here in Linz. So Rustfest, I think, Stefan, that is yours traditionally in the last you can tell those people who weren't here last time a little bit about Rustfest and what's going on.
So Rustfest, it's still the global 2021 edition. It spreads out over a couple of months, and this is the third entry. So Rustfest had 3 editions this year. The first one was Rust in Arts. The second one was Rust Latem, which was interesting because all the talks were, I guess, in Spanish, but they dubbed them. So no subtitles. The organizers dubbed the entire talk as well. So you were able to listen to in Spanish or in English. And this is the third edition. This is the EMEA edition for Europe and the Middle East and Africa. And tickets are still available. The CFP is also currently running. So if you have a talk and can prepare it within a week or so, be sure to apply. The ticket is about €50 or something, but it gives you access to all the editions. So you can also revisit the ones that have already been. And this will conclude Rustfest 2021.
I think that's a really good investment for people who are passionate about Rust.
Absolutely.
Absolutely.
And traditionally, Rustfest always has some really, really great talks. So a broad variety of speakers, a broad variety of topics. Can highly recommend it.
Awesome. We also want to thank our sponsor for this month's Rust Meetup. Our sponsor is Microsoft. They decided to sponsor all our meetups until summer. We say a big thank you. And they asked us to do some announcements, quick announcements, and we will happily do that because of their support. Microsoft is providing a ton of learning resources, including a full course on Rust. So if you are interested, you find it under the link that you see on the left upper side up here. And there is also an interesting spring challenge going on. It's a free opportunity to get Microsoft certifications and even win a backpack. You can use the same link that you see up here. We will also share it in the chat. There are a lot of community events going on, and Microsoft offers some great events for the community. One is the Cloud Native Summit. You see it on the left-hand side, which will happen on March 29th. And the second one is an Evergreen Innovation Camp. It will happen on April the 1st. You see the names of the events here, and you also see the links here. So thank you for our sponsor. Thank you for Microsoft for supporting our Rust Meetup. Okay, and I think that's all I have for you today in the community news. So let's get rid of that one. Stefan, I think it's time to bring Miguel and Wetson up to the stage so we can say a welcome to them. Here they are.
Hello.
Hi, Miguel. Hi, Wetson.
Hello.
We are so happy to have you here.
Yeah, thanks for the invitation. We're happy to be here too.
Absolutely.
Thank you for the invitation.
We are glad that you are here. Where do you broadcast from? Where are you from?
I am broadcasting from Spain, where I currently live in the north of Spain, actually.
Nice.
And Wetson is broadcasting from the United Kingdom, right?
Yeah, so I'm originally from Brazil, but I live in London at the moment.
Cool.
So I'm in central London, King's Cross, at the moment.
Oh,
and
nice.
The weather is nice here actually in London. It's unusual.
Very good. Good to hear that. By any chance, did any of you ever visit Linz?
No.
I've never been there. No.
Oh, you should. One of the best possibilities and one of the best opportunities to visit Linz is in autumn, because one thing that Linz is pretty famous for in the technology world, let's put it that way, is the Ars Electronica Festival. I don't know if you have heard of it. It's one of the world's largest electronic art festivals. It happens for a whole week, and thousands of people from all over the world come to Linz. And yeah, they are there. You can watch exhibitions and things like that. So if you ever want to visit Linz, autumn is a great time. Google Ars Electronica Festival. That's a great possibility to visit our great city.
Yeah, we would have really liked to be able to go in person when the pandemic is over.
Absolutely. Absolutely. So thank you for being with us. And I think with that, we should leave the
Yes.
stage, and the stage will be yours. Let me bring up your slides to see whether the technology is working. I think that looks good. So I think you're all set. The stage is yours. We are very much looking forward to your talk. Miguel, Wetzen, the stage is yours.
Thank you, Rainer and Stefan. Well, this is a talk about Rust for Linux, the project that is trying to bring Rust into the Linux kernel, as you probably know. There will be two parts of the talk. The first is a bit about the status, how it works, an introduction, basically, the goals and the future steps that we will take. And the other half is about a wish list of things that we would like to see in Rust, perhaps, if possible, which Wesson will focus on. Wesson will focus on opinion in particular, so it will be a bit more technical, the second half. And yes, also, well, of course, thanks for inviting us, as we said. Thank you. I also like to thank you everyone that has worked in the project. Here we are only Wesson and myself. But there are also other people that you can see in the patches that we send to the kernel mailing list. There is a lot of people that has been contributing, and we hope more and more people contribute to the project. Yeah, and with that, so let me introduce Rust and the kernel. So in the patches that we sent to the kernel mailing list, we said we want to introduce Rust as a second language in the kernel, right? And some people, of course, say that there are a lot of languages, which is completely right. There are a lot of languages in the kernel. You see here a plot, a logarithmic plot of the languages per file. So the y-axis is the number of files, and as you see, there is a lot of C files, C and header files as well, etc. Then in orange color as well, we have assembly, a lot of assembly files as well. These I put in orange because they also go, or normally, or at least virtually all of them go to the final image of the kernel, right? The final binary of the kernel. And then we have Rust, which so far we only have 100 more or less files. Of course, if it is merged, because as you know, it's still not in mainline. But then there are other languages, as you see. For example, general purpose languages I put, or more or less general purpose languages that are used during compilation or for other purposes, testing, tracing, etc. You see in green here, like makefiles, shell scripts, Python, Perl, etc. And there are other files in blue, the device tree files, Jump, kernel configurations, etc. So a lot of things going on in the kernel, a lot of languages. But yes, what we want to see is that Rust, if it is merged, we want to see Rust as a first-class language in the kernel, and that's why we say it will be the second language in the kernel, second first-class language, in the sense that it would be used for most of the or how you say it will be used for parts of the final binary, the binary that you run when you boot your Linux kernel. Right now, you see only, if you can go back, please, wait a moment. You see that it's only 105, but if we got into the kernel and people start really using, maintainers and developers start really using, and companies Rust, it will grow to roughly, basically, to the same level as C. Maybe not as much, but what we mean is that it will be used. There is one, for example, there is one file per module driver or several files, so it will grow and grow and grow. And that's what we mean by the second language. It's the second language that is general purpose. Of course, assembly is also kind of a language, but it's not general purpose in the sense that you have to write it for each architecture that you want your code running. And why we want to begin with Rust in the kernel is, well, as you know, because if you're here listening to this, it's probably because you like, as well as we like, a decreased chance of memory safety bugs. We say decreased chance because, yes, in safe Rust, in principle, it's impossible, but we use unsafe Rust. There is always a possibility, of course, of bugs in the core or alloc libraries, for example. There is also, we hope that it also decreases the logic bugs because of stronger typing, for example, and other properties of Rust. There is also, we hope that by using Rust, and this is one of the main goals that we want to achieve, is that writing drivers, especially at least in the beginning drivers and other kernel modules, is easy. It's easier than with C. You don't have to pay as much attention to detail with respect to, for example, memory safety. And also for reviewers of that code, because when you submit some code to the kernel, there is people that have to review it. There's a change of reviews, and it would be best that reviewing those drivers is as easy as possible. If I see, for example, as a maintainer, I see that a driver has no unsafe code, then at least I know I'm not introducing those kinds of vulnerabilities into the kernel. And the last point is also very important because, as you may know, in the internal kernel APIs, the things that are not exposed to user space or and users basically are completely unstable in the sense that they may change from release to release. So it's also good to have a language that has a strong typing, etc., so that refactoring all those drivers is easier in the future. And also another goal that we could say is that we have a chance, by using a new language, we have a chance to not fix, but let's say improve other related things. For example, formatting the code, documenting better the code, enforcing some conventions for documentation, writing the safety requirements, etc., etc., etc. So a bit of briefly how it works right now in the support in the kernel. So what we want to achieve, as I said before, is we want to have Rust drivers in the left side of the slide. We want to write drivers in Rust, in safe Rust as much as possible, which call safe abstractions. And the safe abstractions, they basically wrap C code. And for calling the C APIs in the kernel, we are using unsafe. It's possible that in the future, we may, instead of wrapping C code currently in the kernel, it's possible that if Rust takes off, it's possible that we may even write our own, say, subsystems, for example, in the Rust side. But so far, what we are trying to do is wrap the C APIs, the facilities that exist in the kernel already, so that it can be used safely from Rust. So we are not trying to basically rewrite the kernel. This is what it means. And the forbidden line that you see in the bottom means that we eventually, or ideally, we want to forbid that a Rust driver, calls directly the C APIs. It may call unsafe APIs in our abstractions, that's fine. But we want to avoid that they depend directly on the C APIs. We have not achieved this 100% just yet because we have been working on the project, etc., but basically this is the goal, and we don't allow basically to introduce new calls directly into the C APIs. So basically we have to close the gates a bit more, but then we will be able to enforce actually that there is no bindings in the leaf modules, let's say. Then a bit more into detail, going closer into that diagram. As you see, the left side is a driver. We have right now a kernel crate which contains a single crate that contains all the abstractions that wrap the different C structures and APIs, etc. And in order to call the C APIs on the C kernel side, we use Binder, the binding tool that you probably know about, which takes headers or function signatures or declarations in C and gives you unsafe APIs to call. For all this, which we can see the next slide, please, Weston. For all this, we are using currently, basically in the kernel, there is a custom build system, we could say, is called kbuild. And there is a custom configuration system, if you will, because the kernel has a lot of flags, a lot of gates, a lot of options that you can configure at compile time. For example, for changing the frequency of something, or to enable a driver, or to disable a driver, or to make it a built-in or a external module, etc. So that system is kconfig, and all these two together basically do everything right now in the kernel. So for compiling and doing all this to make everything work, we are using the same build system as the kernel does right now. So we don't use, for example, cargo. And cargo we use for build testing, for building a sysroot of the core analog crate, but we don't use it on STD, but we don't use it for compiling the kernel itself. So yes, and with that, the crate that we have, which is what you see in this diagram, the crate that we have and how they are distributed, from the RAS tree, we use the core analog crates. But right now, there is an exception in that we copy the alloc crate into the Linux kernel tree, a subset of the alloc crate, because we need a few new methods and perhaps in the future modifications we have to see. So what we do is we keep it in sync, our changes with upstream. But in the future, ideally, we will be able to use alloc, the vanilla alloc, if you will. Then alloc depends. The kernel crate depends on alloc. We use alloc. We also have a built-in crate, which is to substitute the compiler's built-ins, basically. We also have a macros crate that I have in a different color here because it runs, as you know, it doesn't run in the kernel itself. It runs in the host when you compile. There we have all the macros for the moment. So as you see, it's very like a basic setup so far, where we have all the structures in the kernel crate. We have all the macros in macros crate, etc. We also have other things like sports and helpers, which are basically a workaround, if you will, or a way to call into the C APIs. The helpers go to Bindgen, and the sports are for exporting via a C macro the symbols for external users, for external modules. And one particular thing here with the helpers is that currently, for example, we write all the helpers manually, where a helper is not the headers that we use from the kernel that Bindgen generates, but the helpers are more for example, when we need to use a C macro that is sufficiently complex that Bindgen cannot generate it automatically for us. For example, say a macro that declares a module, let's say. So for those things, we have to create a wrapper function in C that then Bindgen can call it. So it's fine, it works. We have been working that way so far, but perhaps in the future we could devise other ways of making it. Yes, a bit on the status. We wanted to talk about a bit of the status. So far, it's experimental still. It's not meant, the RAS support we have is not meant to be used in production just yet. Not just because we use unstable features, as we will see in a moment, but also because well, there are many things that we have to take care of, details that we have to take care of. But even if it is experimental, it works and it's useful already to work on writing new abstractions for subsystems and other things. It's also useful for writing drivers that work, drivers that are virtually written in safe Rust. And we have already some examples of drivers and modules. For example, we have a GPU driver, and the binder module is not exactly a but it's an IPC, and that works. Yes, it's next. So, and next steps on what we are doing. First of all, for the infrastructure, there are two main parts of what normally when we submit the patches to the kernel main release, we talk always about two parts. One is the infrastructure, the build system, and everything else that has to go into making this work. And then there is the actual RAS code that is probably the most interesting for you. So for the first part, the infrastructure, we want to have a full test framework that allows us to test code, not just in the host, which we already have, but also, for example, the examples in documentation we test. But we want to have, for example, the examples that depend on some hardware feature or some kernel feature. We want to run them in the kernel itself, and we also want to have tests and an easy way to write them to run them in user space for the target. So not in the host, but for the target. these are similar to tests that already exist for C. There is 2 self-tests and key unit tests, in the kernel for this kind of thing. So we want to have parity there, and it's something we are working soon on. Then we also want to upstream and keep as reasonably close alloc in sync with what is upstream. We want to remove restrictions on the Rust support. This means when you configure the kernel, there are a lot of options, right? And some of these options require extra work on our side to support. There are all kinds of options in the kernel, for example, for the toolchain, there are many options that we have to, and features that we have to work on in order to be able to activate the Rust support when the user wants to have them enabled. And many of these are actually used in production, so we need to have the support for that, and we want to work on that. Then we also have to complete the architecture support, perhaps even add more architecture. We have a few of them as examples, basically. And then on the other side, the abstractions and drivers, of course, more and more facilities. Basically, this means wrapping more and more data structures, more facilities from more primitives from the kernel side. For example, we have a mutex. We want to have, ideally, we would like to have every single facility in the C side to be able to be usable for the Rust drivers as well. We are working on a DICE module as well as an NVMe one. We're also working on working support. Basically, Wesson is all doing this work, and he may talk about that later a bit. Then finally, and this is the most important goal, is mainlining, which means getting merged into the kernel, because the previous 2 slides are about what we are working on, right? In order to accomplish this, which is the main goal, which is getting into a kernel so that people can start actually using it and are confident that even if it is merged as an experimental feature, at least people can see that it's there, it's working, it's being tested with the rest of the kernel code, and we start iterating there. And in order to do this, there are 2 main, we can say, things we have to accomplish. One is getting support from as many kernel maintainers as possible. For example, if we want to have GPIO drivers in the kernel, we have to actually contact the GPIO maintainers because the kernel, as you may know, is like divided in many sections and subsystems, subsystems, and there are maintainers for each piece, for each of these pieces. And we don't want, and we cannot really be experts or try to write all wrappers and have knowledge on every single of these subsystems. So the idea and what we want to accomplish is that key maintainers of some individual sections of the kernel that want to use Rust and that they want to use it as early as possible, have them on board, have them review the code, understand the code we're writing, even if we write the code in the beginning, but have them understand it and support us there. And then if the Rust support becomes non-experimental at some point, then they will be already ready, because that's basically the main thing. So one key thing is getting support from kernel maintainers. We have already support from a few of them, but we are looking into getting even more and more. And for that, a second thing we have to do is providing learning resources, documenting things we are doing as much as possible, answering the questions from maintainers, from other kernel developers, etc., so that they are confident that first, this works, this is an improvement over what we are doing in C, and yes, basically convincing, if you will, everyone, the people that is on the, that there are, of course, people that don't want this in, there are other people that want this in the kernel, so we have to convince those that are in the middle, basically, and they are still deciding whether the extra complexity, the extra burden of learning Rust is worth it. And then and then we have the second part of the talk, which is a bit of a wish list of, I mean, first of all, we are not experts in Rust. We know we have worked with Rust, but we are not experts in that sense. So basically, we have been using Rust to the best of our abilities, and we have found some things that we would like perhaps to not improve or to fix, but perhaps things that we would like to have, or things that we think would be an improvement to the language if they were there. First of all, this is what I said. We this wishlist, we are going to focus. Wilson is going to take after a couple of slides. He's going to speak about pinning. But there is a long list of wishes that we have, and you can see the Rust CTCFT session there where we were invited to talk about this wish list, and we go into detail there about things that we have seen. So the first thing are the unstable features. Of course, this is the obvious one, right? We keep a live list of unstable features we are using in that link, but ideally. Ideally, we want as soon as possible to not get rid, but to find a way to compile the kernel with as few unstable features as possible. It's not really, it may not be required to reach the point where we are in a stable completely, but we really need at least a promise that those features will not suddenly completely break. At least when the kernel decides that it's going to be used in production, basically. So we can get merged. This is fine for the moment. But at the point where we want this to be used in production, we really have to say this is the point where code will not break in the future, at least not in a major way, let's say. So these are the unstable features. I keep the list here. The ones in bold are like the important ones that currently we have. This may change. But yes, as you see, there are quite a few. There are others that can be workaround. The ones that are not involved, maybe workaround or not. But yes, if you want to have more details, go to the list or to the talk that I described. And then just to start a bit with the wishes, this is an easy one that we want to highlight, which is having unsafe op in unsafe FN. This is a lint currently in Rust, as you probably know. Where having it denied means that the unsafe functions don't have an implicit block in them anymore. So you can go, the language would change from writing, for example, something like in the left to something in the right side. We think this is, we agree with making it a hard error because we think the language should be like this by default. We think it's orthogonal, whether a function is unsafe or whether it contains unsafe blocks. And yes, we would be, it would be really great, for example, for Rust 2024, it would be the default. I mean, this is not something we need in the sense of an unstable feature, but it's a wish that we have. And with that, we have the pinning side of talk, which Wilson will talk about. Wilson has been working a lot on the abstractions. He is doing the main work on the abstractions and the driver details, and he has been fighting with pinning for a long time now. So he wants to give you his experience with pinning and where it could be perhaps improved. With that, thanks. And Wilson, all yours.
Thank you, Miguel. Yeah, so now we're going to as Miguel described in the beginning, we're going to switch gears. It's going to be a little bit more technical with more code and some diagrams here. So we're going to talk about pinning, and the reason pinning is important to us is that in a lot of drivers, in fact, some real production drivers that we convert or we look into, pinning is the one source of unsafety for us. So really, what we'd like to see is these unsafe requirements, like the need for these unsafe blocks to go away. So we're going into some of the reasons why they are needed at the moment. Before we go into that, a little bit of background on this principle that we follow and that Miguel already described briefly in previous slides. But the principle is that we reuse existing C kernel code. We try to avoid reinventing the wheel and re-implementing things in Rust if they're already available in C. And well, the main reason is that the subsystems are currently written in C, so we do have to interact with C at the moment anyway. Even if we didn't want to, we have to because that's where the code is at the moment. Most of this C code is battle tested in production. It has been used in production, and at least for the happy paths, the common paths, we know that they work. Another reason is that, and in fact, this last reason that I have listed there is mostly for cases when we already have a Rust implementation of something, and we also have a C implementation in the kernel. and in most cases we end up choosing the kernel version over the C version. And in most cases is because there are certain choices that we can make when we are writing code, and these choices are in some cases different between user space and kernel space. And I'll give you a little example in the next slide about a case where we see these kinds of choices and where things make sense in one case, but not as much in the other case. So we use this reuse existing C code, and then people may ask, well, if we're using C code, what's the point of doing Rust, right? It would be no better. And as Miguel already pointed out in one of the previous slides too, what we are doing is we are building this safe and hopefully zero cost. And I'll have a little bit more to say about the zero cost here, abstractions around this C code, right? So what we are doing is we have C code that we want to reuse, but we abstract it away in a safe way to Rust code, Rust drivers, and the idea is that we'll benefit from this, well, from the safety properties that Rust offers us. So here's an example of we feel is a successful example of reusing existing C code in the kernel. So what we had here, the options is in Rust we have Arc, existing Arc, and it's in libalog. So we could use it if we wanted. And in fact, when we started, we were using this. And we have a competing implementation of this on the C side in the kernel that is refcount T. Okay, they are slightly different. So they both just do reference counting and atomic reference counting, meaning that we use atomics to increment and decrement ref count, so they can happen concurrently. But the implementation is slightly different. The C version has less features. It doesn't have like weak references, for example. So they actually, the implementation uses just one 32-bit integer of extra space that needs to be allocated when you allocate an object, whereas the Rust version uses 2 words. But this is not all that relevant. I mean, basic differences. But the most relevant difference for us, and this is what drove us to replacing Arc, removing Arc basically from our. So we never use Arc anymore. We use this other thing that we implemented. Is the behavior when these counts overflow, right? So if you actually have a bug in the code where you forget to decrement the ref count in some code paths, and in fact this is harder to get to in Rust, but it can happen, right? You can actually forget a ref counted object, and then the drop doesn't get called, and so the decrement never happens. This could happen in Rust too, and it's not unsafe for this to happen. However, this can be a source of unsafety if attackers notice that this is happening, and they actually trigger the repeated leak such that eventually we overflow this count, right? And then when we overflow this count, if nothing is done, what happens is that the count goes to 0, right? We think that, actually it goes to 1 eventually, and then one successful decrement brings it back to 0, and then we think that we need to free it, and then we free it, and now we have a dangling pointer, potentially several dangling pointers, actually the same, pointing to the same place that has been freed, but in several places potentially. Anyway, so there's a security issue there and a safety issue there, memory safety issue there. So what we have to do is we have to realize when these overflows are happening, and we have to react to that. What Rust does really is aborts. It aborts the process. It stops running the process. It's not a panic. It's an abort, right? Which makes sense in user space, right? You're running a process and in some inconsistent state, we just want to kill it and have it restarted if it's a service, for example. It makes sense in user space. But if it's in the kernel, what we're doing is we're bringing down the whole kernel. The whole machine is coming down, or virtual machine is coming down because of this. So we'd like to avoid that. And what the kernel does is it saturates the count, right? So when you see it's about to overflow, we put it at some value, and we leave it at that value. So we never free the memory. So we have a leak, but we don't violate safety basically, and we keep on running. Well, we did that, and we made it look very much like Arc, and actually to do that we had to use some unstable features. So this is actually one thing that we'd like to see stabilize. If you can think of, if you want to split things in themes, the theme here is let anyone who wants to replace arc to be able to replace it without having to use unstable features or compiler internal features. But anyway, since we were implementing a new version of that, we made some slight changes too. For example, we removed get mute, which means that it's pinned automatically. So when you allocate some memory and it's ref counted, it's pinned. Now, why does the spinning matters to us, right? I've been talking about reusing C code, but what does it have to do with pinning? And the answer is a lot of the kernel data structures on the C side are self-referential, right? And the problem with it being self-referential, and by self-referential I mean that there are fields in it that point to itself, right? It can be direct points a field to another field or to the top of the struct, or it can be indirect, right? Well, like a field points somewhere else that eventually comes back to this object. So we can have this self-references, can be direct or indirect, but we have lots of those. We have them all over the place in the kernel. In some cases, we actually need them to, we need these objects to be pinned. What's the relevance of being self-referential to pinning? And the relevance is, if there are these self-references, we want to have this pinned so that they cannot be moved. And because when they are moved, then these pointers don't get updated. And I'll show you in more details in a second how this happens. So on the C side, we actually have some cases when we need to pin these objects from the beginning. So right after we allocate the object, we need to pin it before we can use it. There are some cases where we don't actually need to allocate it right away, but like we don't need to pin it right away, but later on. And I'll show you two examples, one for the first case and another one for the second case. And I'll show you what the problems are and the ergonomics and some possible solutions that the language may choose to adopt in the future. So let's get started with the first example, one in which we need to initialize things before they can. We need to pin things before they can be used. Here we have. Let me see if my highlight. Yeah, here we have the definition of a mutex in the kernel. The actual fields are not all that relevant for our discussion, but I'll point one thing out is when these mutexes are used in the kernel, the way they're used is usually you have this mutex declared somewhere, and then before you use them, you have to call this mutex init function, which takes the mutex, not initialized yet, it will initialize it. Some extra arguments that are not relevant to our discussion. They're here just for completeness. But amongst the fields here, there's one that is very interesting, which is this waitlist, which has type list head. And this is actually, as I point out here, it's a intrusive, circular, doubly linked list, which means that when we initialize it in this mutex init, what we're going to have in this, we're going to have a struct like this. There are some fields here, and then this is the waitlist. There are two fields within this waitlist, next and previous, right? When we initialize them, next points to waitlist, and previous also points to the waitlist. So this is the part that I say it's circular, right? And in here we have the self-references that I was talking about, and in this case it's actually a direct one. We have the object pointing to itself. Okay, so this is on the C side. On the Rust side, so this is our abstraction, and if you look at it, it basically boils down to a mutex and the object that we are protecting, the implication of having this mutex here is that we have the same sort of thing happening on the Rust side as well, of course, because it's just wrapping the C side. But we have our mutex instance here. We have some fields here which are coming from mutex. We have some other fields here also coming from mutex, but we also have our data down here. But the idea is that next, if in our new, for example, we call that mutex init, what we'd see is that we have this next pointing to the list head, and the same thing for previous. Previous would also point there. As I said before, there's an issue with that, and I'm going to show you this diagram is the one that brings this home, right? So this is how things are initialized. This is how things are done normally in Rust. There's nothing unusual here. Okay, we have some struct that has some inner field that is a mutex, right? And this ref is our implementation of Arc. So we're trying to create a ref counted instance of my struct that has a mutex in it, right? So if we look at how this would be executed at the runtime, this is what we'd get, right? There is a call to mutex new. We initialize our pointers if we call mutex init then, and this is allocated on the stack, okay? And then what happens is ref new is called with this mutex initialized on the stack. And in fact, there are two stack instances here that can be optimized out. So given that this optimization exists, I will consider that there's just one for our argument here. So we are in this state, okay? And then we call ref new. Ref new actually allocates some memory on the heap, right? That is ref counted. And eventually we'll have something like this. We have mutex and we have the ref count up here. But this is on the heap, right? And what it does is it moves this argument here into this new heap allocation. So this object that we had initialized here with those pointers pointing to itself are just going to be copied bit by bit to the heap, right? And so the situation we end up with is this one, and this is our source of problems, right? It's because now our heap allocated and ref counted thing that has a mutex in it now has pointers to the stack, right? And to not only to the stack, to an object that existed in the stack, and it's going to be automatically popped from the stack, so it's pointing to memory. It's a dangling pointer, basically. And whenever we try to actually access this, we'll mutate this stack region, and this is really bad. That's the source of lots of vulnerabilities. It's these sorts of things that C allows you to do. And we're trying to prevent that from happening on the Rust side. So what did we do to address this problem, right? So we defined this new constructor, and we had to make it unsafe, right? So the idea here is that the mutex initialization doesn't happen in our new. Our new just uses some uninit version of that mutex, and the safety requirement, which we annotate here. So this is actually a convention that we use. Miguel talked about having improved conventions, or not improved, new conventions that we can enforce from the get-go because this is a new project. So we actually have this convention where we say, if you define a unsafe function, you must have a documentation section, and that must have a safety section in it. And you must specify what it is that you need the caller to do in order to use your unsafe function safely, right? So what we do is we say, well, after initialization, you can move it, you can do whatever you want, but before you actually use the mutex, you have to call init lock, okay? And this is the source of unsafety for us, and this is the result of our implementation, the poor ergonomics, right? We have initialization has to be done in 2 steps. First step allocates the object on the stack, and at the moment we use this unique ref is to be able to initialize objects, and we guarantee there's only one pointer to it. And this is a result of us not having the get mute anymore. So once the object is shared, it cannot be mutated anymore because it has been pinned, right? So when you allocate, you make it unique ref. But anyway, it's not relevant here to the discussion at the moment. But we do mutex new, right? And we can move it around, and it's all fine because the pointers have not been established yet. And we have to have this safety annotation here saying that mutex init is called below, and we have a macro to do that. So this is the problem with the ergonomics that we have today. First, we introduced the unsafety, and now we're forcing people to have to call this mutex init. Now we've looked into trying to avoid that. For example, options are doing things like when you call mutex init, instead of returning a mutex, you will return some other type, right? That cannot be used as a mutex only after you initialize it, and then you have a mutex type. We could do something like that, but it wouldn't work here because we actually need a mutex type to initialize inner in this case here, because inner is a mutex to this inner type. So this is the state we're in now with the poor ergonomics. What one possible solution for this is to change, instead of actually. Before I talk about this thing, there's another unsafe here which I'll talk about too, because it's related to projection. I'll talk about it in the next example. But so what we'd like to see really is something like this, right? Still 2 steps, but with no unsafes, right? The idea is we call try new uninit, right? So we're basically creating an instance of mystruct that hasn't been initialized yet. So it's maybe uninit mystruct here. And then here we initialize all the fields of mystruct, and then eventually we call into, which converts it from unique ref maybe uninit to just ref of mystruct, right? And the hard part here is that we need to ensure that all the fields have been initialized, right? So in fact, we can already do this nowadays with unsafe. Like if we do something like this, and here we can use adder of mute and initialize all the fields manually. And instead of doing this into here, we can do assume init, right? But this assume init is itself unsafe. So we'd like to avoid that. So what we need from the compiler is a way for the compiler to, between these 2 blocks, ensure that all the fields have been initialized. And of course, we don't want like a general solution to all possible ways that somebody could write some code here, because then we get into the halting problem and having to do static analysis, and it's impossible, basically. That's not what we're asking for. We're asking for like a very limited sort of solution, where perhaps we just have statements here that initialize each one of the fields, right? And what we'd like to see is the compiler check that for us. And if we leave one field out, then the compiler fails compilation for us and says this is it's not fully initialized. So we can't safely assume that it is fully initialized. And this sort of thing already happens when you, if I go back to the previous step, when you do something like this, if you do like mystruct and you do the curly braces and you put the fields in here, the compiler, of course, checks that you've specified all the fields. And if there are some fields missing here, then the compiler fails the compilation. We want something similar to that, but instead of having the curly braces and the types colon and some function, we actually want to have pointers to these things and to be able to initialize them in place. So this is what ideally we'd like to see. Another thing that I should say here is this is one possible solution, right? If people come up with different ways that allow us to do the initialization, we'd be happy with that too, as long as it's like it doesn't have as poor ergonomics as we have at the moment with all the unsafety. So this is it for the first example where we needed pinning to happen before things can be used. We'll go now into the second example, which is when we need pinning later on the lifetime of an object. And the problem here is one of projection. And the example we have here is MISC devices. The way MISC devices are implemented on the C side of the kernel is you have to specify a pointer to a struct of this type, and you have to initialize some fields. And then what the kernel does is, once you register, is it uses this field here to add this MISC device to a doubly linked, intrusive, and circular linked list, the same type of list that we talked about. One thing that I should say here, there's actually a talk or Q&A with Linus Torvalds where he talks about taste in programming, and this is actually the example that he uses. Because one possible solution for us would be to say, oh, let's not use lists of this type in the kernel, right? Let's use something else. But perhaps in the future we may try to do this, but this is not something realistic now. Another thing that I should say is I've worked on other kernels. So for example, I worked on the NT kernel, which has a huge code base. I've seen some BSD kernel code too. And all three of these, one data structure that they have in common is this sort of lists. The implementation is slightly different, but the idea is the same. It's intrusive, it's circular, and it's doubly linked, right? And gives you lots of advantages. And that's why pretty much all the kernels use this. We don't need to get into that. But basically, here we have this list, this struct that has a list in it. And here, the self-references are indirect, right? Because what happened in the first case was we actually had a list head and the list head was just pointing to itself when we initialized. This one, there's a list head somewhere else, right? And this element, this instance, is being added to that list head. So the self-reference is interacting in the sense that we have next is going to point somewhere, that may point somewhere else, that eventually gets to the head, and head points to this misclav, and this is where the self-reference exists. So our abstraction is one called registration. It's a registration of a MISC device. We have new, which unlike the mutex case, it's not unsafe, so it's okay to allocate this because we don't have the self-reference yet. But then when you call register, you are required to pass a pinned version of the thing. So between new and register, you have to pin your object before you can call register. And between these two is where our unsafe requirement is in most cases, and we'll talk about it in the next slide. But before I go there, I'd like to point out that we actually have this helper function here that's called new pinned that will merge these two things, and there's no unsafety involved here, right? So what it does is it allocates a memory, pins it, and then calls register. And here's the type: it's a pin box, right? It's not just pin. It's a pin box. The problem with this is that, well, it's not a problem. One fact about this is that it allocates memory, right? And so it's not always the thing that you want, and I'll tell you why in a second. So why is that an issue? I've already sort of talked about this. As I said between new and register, you actually need to pin your object, right? So the idea is, if you have a struct, and in this struct you have multiple objects that need to be pinned. Okay, for example, you have a mutex inside the thing, you have a misclav registration, maybe you have a net filter registration. They all need to be pinned, right? So you actually have the option to do the dynamic allocation. But then what's happening is you have a field, you have a struct with 3 of these, then you have 3 allocations plus the allocation of the extra object, which is not something that is required in C, right? And this is what I try to this is what I'm alluding to here in this item, where I'm saying this prevents the zero cost, right? And if we were to only provide the new pinned version to users, then the people who are used to C and doing things just the C way would like point out to that and say, oh, you guys claim that you are zero cost, but you clearly are not. There's more allocations here, and it's not just the fact that we allocate more. There's the locality of data and cache lines, and the people working on such low-level code, in not always, but in a lot of cases, they do care about this. They do care about the layout and how to optimize the cache lines such that fields that are used together are closed and are close together and share a cache line. So this is the situation we have now. To actually, if we have in this case, we have the outer object P is pinned. The object itself is pinned, right? But the fields of this object are not necessarily pinned. And to claim that they are pinned, then you need this unsafe block, which does the projection, and then you can call register on it. And this is the other unsafe that we saw even in the mutex example. Okay, go to the next one. A possible solution for that. And in fact, there's a crate that does that with a proc macro, but we're trying to avoid that, and we can talk about this in Q&A. But so what we'd like to see is really language support for this sort of thing, right? So for example, in annotations, right? So when you declare your my struct, right, you could perhaps add some annotations where you say misc. If my struct is pinned, then misc is pinned too. Right, and it would prevent us from doing all the bad things that one can do by doing the structural pinning in projections, right? But to also allow us to do something like this, where there's no unsafe involved. We can just do p.misc.register. We can go straight to the register, which requires a pinned mutable reference. And with this, this is the end of it's right on time, I think, 25 minutes of our incursion into pinning. So if you have questions about this or anything else that Miguel and I talked about, we'd be happy to try to answer. Okay, there's a question here.
So I'm sorry, I don't know if this was intentional that the question pop up here. So give me a second to start my camera again. Hi. So thank you for your talk. I try to reach Rainer. Rainer is back again as well. Hello. So so thank you. There was one question. I guess you read it already. Let me bring it up again real quick because Zishan is asking that the Rust convention is to use fine-grained logs in the fields. It doesn't think that it helps with the pinning problem, but it's curious if you have used the single mutix on the top for a specific reason.
So actually, I should have talked about this, but I'm not using one at the top. So if we go to the example here, I didn't mention this, but where is this? Yeah. No, here. So here's the example, right? The idea here is like the top is my struct. It's not a mutex, right? And this dot here is that we have other fields, right? And then one of them is inner, and that inner is a mutex. And in fact, we could have several of these, right? And in the example, in the binder case, we actually have some structs like this, which have different mutexes for different things. So yeah, it was. I'm sorry if you got the impression that I was using it at the top, but that's not what I meant. I actually meant to have fine-grained, as is the recommendation in Rust in this example. Does it make sense? Can the person who asked the question?
I'm sure Zishan will answer that in a couple of seconds. We have a little delay from what we're seeing here right now until it gets to the other folks. In the meantime, I will continue with another question from Yarsi. Is there any issue upstream in the Rust repo for requesting lang support for pin projections?
As far as I know, I'm not aware of one, but if you think we should create already one, I mean, we didn't want to create it too early because sometimes the Rust process, as you know, requires an RFC or a pre-RFC, etc., etc. We create issues for other things, and we have even created at least one RFC already. But for that one, we thought we could first need a bit more discussion before. But if you think it's good, we can create it.
Yeah. So just to add to what Miguel said, we've talked to some folks about this, and they said, oh, you should do the MCPs and pre-RFCs, and the reality, at least for me, is that I'm not very familiar with these processes on the Rust side, and I don't know much about the internals of Rust, and I'm already fully consumed with the internals of the kernel to try to abstract this away. So I actually don't have the cycles. As much as I would like to have them, I don't at the moment to go through all of this, right? So what we're trying to do really is to talk about these things and have people look at it, and people who know about the internals of the compiler, and perhaps propose ways for us to do things differently. We're actually open to doing things differently too, as long as we can address the problem, right? And perhaps either propose different ways of doing these things, or perhaps trying to lead the effort to bring these things to the compiler, right? Would be very happy to support that.
Yeah, we have Bjorn 3 and Gary Guo having helping a lot on the Rust side of things, on the compiler internals. They have been very helpful so far.
Yes, he had 2 comments on that. First, they change the process constantly, so that's totally fair. And leading the effort is the most helpful thing from their perspective. So cool, great. And also, Zishan is sort of happy with the answer, but I'm pretty sure if Zishan wants to reach out to you, I guess you're open for further questions, etc. So great.
If I didn't answer your question, feel free to. I'll be available on the Discord later if you want to talk.
Cool,
or
great.
If you want to specify more here, I'm happy to try to.
Fantastic. There's another question. I guess this is from Matthias, who has done one of the first kernel hacking talks at Rust Linz, if I'm not mistaken. Is it possible to build kernel modules completely separately from the kernel, or does he have to clone the kernel and develop the kernel module there?
So Right now, it's possible. We have support for out of 3 modules. It's what they are called in the kernel, out of 3 modules. But having said that, because the Rust support is not in the upstream kernel, and the Rust out of 3 support depends on the code that we have in the kernel image, in the built-in kernel. You need support from the host kernel, let's say, not the host, not called the host, but basically you have a kernel, a running kernel, and when you want to load your Rust module, the idea is that this kernel has the Rust support, which contains the kernel crate we talk about. So basically, there is support for out of 3 modules, but the kernel you want to install it to has to have Rust support enabled. And in fact, the abstractions that you may want to develop in your out of 3 module, you should try to do them in the kernel crate, and then have the driver use those abstractions. I mean, the idea is not to have basically duplicated core alloc in every single kernel module, and not just core and alloc, but also, for example, the mutex Wesson has been talking about, you will need to duplicate everything. So that's not the idea. The idea is not to have big modules that use Rust. The idea is we have all the Rust support in the kernel, and then there is very small modules. And actually, the Rust modules we have right now, whether out of 3 or not, it doesn't matter. They are actually similar in size, same order of magnitude. They are a bit bigger than the C ones, but they are roughly the same size as the C one, which is very good.
Yeah, I actually I ran a code lab session last month, and we actually did that. So I compiled so I got the kernel, I compiled it once, and then the code lab was a out of 3 module, right? So it is possible to do, but somebody needs to compile the kernel once, and make it available to you. That's basically what Miguel was trying to say. For existing C distributions, that already happens, right? Somebody compiles the kernel and makes it available. So you just use that. But since we're not upstream yet, nobody's doing that for us yet. So it needs to happen.
Yeah, I send the link right now. If we have the example, the template. If people want to play with out of 3 modules, they have the template there.
I will put it online in a second.
So you can clone that. As soon as we get into the kernel, into the upstream kernel, and you are willing to compile one of the latest kernels, basically, so you have to compile a very latest kernel. Or perhaps at some point, if your distribution happens to give you, if one distribution, Linux distribution, compiles the Rust support, perhaps in an alternative kernel, not the production one, then you could only use that template, right? But so far, you will need that template plus so what we recommend, at least what I recommend, is just do the driver in 3 for the moment. Just clone the main repository and do the driver in 3. You don't need the out of 3 template, really. If you are playing it right now, it's easier just to go with the full kernel.
Very interesting. Thank you very much. Wetson, you said this is the end of the pinning part. Do you have additional slides that you want to share with us?
No, that was the end of
okay. Fine. I was not 100% sure, so I thought it would be a good.
Yeah, sorry, I just saw your question in the private.
Yeah, we weren't entirely sure.
Absolutely. Yeah. Let me check the Discord server whether we have additional questions. Currently, we don't have questions. I found it super interesting, your talk, because I am a safe programmer. I live on the, what was it, the blue pill? I think this is where I live. So I write application code, and it was very interesting to hear the things that you guys are working with. Thank you for sharing that. Thank you very much.
So one thing before we continue, because I constantly forget to do it, but I would ask to everybody in the chat to put out your clap emoji and give a round of virtual applause for two speakers, Miguel and Wetson. There they are. So there is a little delay, couple of seconds until you get them. But while we're waiting for the clap emojis, thank you so much for being with us. This was super interesting. I'm Justice Reiner. My connections to real low-level systems programming are almost zero, and I'm constantly amazed about what you're doing. So that's fantastic work, and
absolutely
really looking forward to what you're up to in the future.
Absolutely, and I really think your work is super, super valuable because Rust shines when it comes to safe programming and memory safetiness, and bringing that to the Linux kernel is super interesting. And thank you very much for all the work that you do in this area.
Yeah,
Thanks a lot.
Thanks for the opportunity to talk about this.
Absolutely. So thank you for being with us. If you have some time and if you want, you are very much invited to join our Discord server. There you will find a lot of the people who just watched you and who asked the questions. And if you want, you can deepen the conversation and continue the conversation there. Stefan, thank you very much for putting the link to the Discord server up here again.
Yes, I'm definitely going to join.
Yeah, I will join too.
Cool.
Thank you. And if you take a look at the chat, I see clap emojis all over the place. So people are happy with you.
Thank you, everyone.
Thanks,
you,
everybody.
Miguel and Wedson. Thank you. Have a nice evening, and we hope that we will see you in the future again at the Rust Linz Meetup. Thank you.
Thanks. Bye.
Bye.
Okay.
Stefan, I think it's time for us, right?
It's time for us.
Yeah. Exactly.
Already. So I just shared my slides. Are they? Yeah, they are coming up. Cool. Alrighty. So a little bit web stuff to unwind after all the Linux kernel stuff. So this is. Are we ready, Rainer?
We definitely are.
Cool. Let me get on my notes. Alrighty. So this is a little impromptu talk. So over the weekend we asked around for a second speaker, a second group for our meetup, and we decided in the end, since we found nobody, that we have a little topic up our sleeves that we want to present to you, which is an introduction to WAGI or WAGI. Or the WebAssembly Gateway Interface, and what it means. I'm coming to that in a couple of minutes. And Rainer and I split up. I created some slides. Rainer created a ton of great examples. So I already looked through the repo, and this is fantastic. So there's lots of good stuff in there. But before we give you an introduction to WAGI, I want to create some context. Why we are having a tool like that, what's the deal behind it. And I want to open with this, I guess, now famous quote by Solomon Hykes. If you don't know about Solomon Hykes, he is the creator of Docker. And a couple of years ago, he said that if WASM, WebAssembly, and WASI, WebAssembly Systems Interface, had already existed back in the day when he created Docker, he wouldn't have had the need to create Docker. Those are some big words. And everybody wondered, what do they mean? Why is he tweeting something like that? And for that, you have to understand a little bit about WebAssembly or WASM and WASI. Lots of acronyms today. So for you who don't know, WebAssembly is a binary instruction format for a stack-based virtual machine. It has been designed first for the browser, but it's actually intended for much, much more. And this is what we're going to look on today. We are going to look about WebAssembly outside the browser. Why it's a good fit for outside the browser is because there are two very important principles baked into WebAssembly. The first one is that WebAssembly is an assembly language for a conceptual machine. This means that it needs a runtime, and this runtime can across a variety of different machine architectures. This makes WebAssembly programs incredibly portable. And this is something that we see already. So WASM is available in all major browsers. This is peak portability. And the other one, since it's available in all available browsers, WebAssembly needs to be really, really well sandboxed. Code that runs in the WebAssembly VM is not allowed to talk directly to anything on the operating system. The host needs to provide functions to access operating system capabilities. And those exceptions need to be made explicit. And just as WebAssembly is a language for a conceptual machine, it needs a system interface for a conceptual operating system. This is a quote from an article that I'm going to link on later. And this leads us to WASI, or the WebAssembly Systems Interface. What the WebAssembly Systems Interface allows us is to access stuff in the real world from our WASM code, like files, sockets, I/O, all that good stuff that makes software really, really fun. And this allows us to run WebAssembly outside the browser. So instead of compiling our software down to different operating specific targets and run them on the system interface of the respective operating systems, we compile it to WASM, run it in a WebAssembly runtime that has access to operating system specifics. This is from an article by Lynn Clark on mozilla.org, which is a great introduction to the entire WebAssembly system interface topic, which I can highly recommend. Also, I'm going to link that after the show. So, some really quick code on how this looks like. This is, if you will, the hello world of WASI. What you see here is some Rust code. What I'm doing here is I'm opening a file based on some command line arguments. And then I load this file and put it on standard out. This is all it does, and this would work totally fine if you compile it down to a binary on your respective architecture, you run it, and as long as your Unix, Linux rights or Windows rights are correct, you can access the files and put them out. But if you run it, if you compile it down to WASM32 WASI and run it with a WebAssembly runtime, it will bamp. Give it, where's the animation? Here it is. It will error. And this is great because this is pure isolation. The WebAssembly runtime has no access to anything outside until we give it access to, for example, a lyrics folder. And then it can find stuff, then it can load files. And this happens via the systems interface. It doesn't seem like much, but this is exactly the kind of isolation that Solomon Hykes was referring to. So you have to explicitly open ports, you have to explicitly open folders, you have to explicitly set free directories. And with that, you don't have any need for operating system virtualization, no need for running Linux images, etc. You compile it to a format that is secure by default, and you open up what the software is supposed to read. No surprises, because some strange directory with sensitive information has the same access rights as Stairway to Heaven from your demo app. And this is the promise. And this is the promise that leads to all those projects that evolve around WebAssembly systems interface and WebAssembly. We can run workloads fully isolated and container-free. And there are several projects that build upon this promise. Crustlet has been here a couple of times in our meetup. So we had the creators of Crustlet there and Thorsten Hans, who showed an extensive demo on Crustlet. And this is WebAssembly on Kubernetes. And this, is good for cloud architectures. This is great if you want to run WebAssembly in Kubernetes, but there's more than Kubernetes. And from the same creators comes a fun experiment that goes directly back to how we created backends in the 90s and early 2000s. And not only because of that, this is an experiment that I like a lot. And the experiment that I'm talking about is WAGI, the WebAssembly Gateway Interface. And before you see it in all your glory, cast your mind back to the late 90s, where you did change mod 177 on a Perl script into your CGI bin folder to get some bulletin board entry from 0cool82 written on your disk. Everybody did that with the best intentions. Like, oh, if the script doesn't run 777, then it should work. Of course it did. But there were also some implications. And that's right, I'm talking about CGI, the Common Gateway Interface, the most used technology back then to execute some code on the backend. Still used today, so if you run some PHP, you have to have some CGI because the principle is still the same. It looks like that. It's meant for HTTP requests that come to a server. The server is CGI capable, and based on the request can execute the CGI script, quote unquote, over the CGI gateway. Back in the 90s, they were mostly written in Perl, PHP, but there has been also some C and C++ programs that are executed like that. And this means this is really an execution. This is an invocation. So you kick off the software writes on standard out, and what you read from standard out, you transform into an HTTP response, or your standard output becomes the HTTP response. And there's something very important here. You have a per request invocation. Every time a request hits, this process gets kicked off anew. And and this should remind you of something. So if you squint a little, if you look a little closer, that's like serverless apps. This is there's some nuances like how runtimes are bootstrapped, and if you have a warm container and how you send responses, but the main concept and the main idea behind it is roughly the same. A request triggers a fresh invocation. And with CGI, we had the problem that we have insufficient isolation. With serverless apps, we have really, really good isolation, but they come with this runtime thing and lots of implications on top of it. And this is where we can rely on WAGI, the WebAssembly Gateway Interface. So it's the same principle. You have a server. WAGI is based on a Tokyo Hyper server that, based on a request, executes a WASM file on your disk. And you can set some features for this WASM file, like access to a folder or access to some network that we are going to see, based on some configuration. So modern languages, modern tools, perfect isolation, party like it's 1996. This is a Hello World in WAGI. I don't want to bother you too long because Rainer is going to give you a ton of examples there. But one thing that is important here are those 3 print lines. I want to focus a little bit on them just for a second. The first line, we are defining a content type to explain. Then we have an empty line, and then we are writing Hello World. This is HTTP 1. So this is the beauty of this wonderfully old protocol, that you can just write lines, and based on what you're writing there, you have an HTTP response. This has been completely lost with HTTP 2 and 3. This is an undeniable beauty here. Because this line here, this line break, denotes when the header ends and the body starts, when you basically are done with all the header information from your response, and when you can start with the actual body. And this is a sample configuration from a modules file, but I don't want to go into detail here. This is what we're going to see right now. I'm going to stop sharing and hand it over to you, Rainer.
And I am going to share now. Thank you very much for this awesome introduction. Thank you, Stefan. In the upcoming, I don't know, 20 minutes, 30 minutes, I really haven't tried it. We'll see how long it takes. I will show you 4 samples. I split them up into levels. So we have level 1 until level 4 with raising complexity. And I will try to show you all of the things that Stefan just told you with live code. Of course, I will not type everything because I'm too slow in typing and it would be too much code. So I will copy in some stuff, but I will definitely make sure that you can follow and that you understand all the things that are going on. One note at the beginning. All the stuff that I'm going to show you is experimental. So things can break, things will break, and I will mess up with a very high degree of likelihood. So please bear with me. Maybe we will have to do some bug fixing, and I hope that, Stefan, you will look at my fingers and point out when I do something wrong. So let's get started with this one. So the first thing that I would like to show you is this one. So if you are interested in the code, this is the code. And maybe, Stefan, if you have a minute or so, maybe you can copy out this banner and put it into the comments so that people can take a look at my code, because I'm using a ton of features and tools in this demo, and you might want to have some links here, and I gathered everything in this GitHub repository. That was the first thing that I wanted to show you. And then let's get going. So here we are. I created a brand new folder here in my Visual Studio Code, and we are going to start with a brand new application. Let's call it level 1, because this is what we are going to do, level 1. And let's copy in some code that I have prepared. This code is not particularly complex. It's exactly that one. And this is the code that you saw from Stefan. It's really, let me show you the cargo toml file without any libraries. So I'm not using any fancy libraries to build a web application. I'm just printing out stuff on standard out, as you can see it here. And believe it or not, Stefan told you that's a web application. That's really a web application, and we will try it immediately. First, let's create some housekeeping stuff. The cargo toml file that we need in order to create a workspace, and let cargo know that there is a project called level 1, and we will add additional levels later on. Now, the next thing that I am going to need is this file here. It's just an environment file. We will need that one later on. When we run WASM and we have some errors, we want to have some beautiful stack traces, and this environment variable makes sure that we get some stack traces. So this is just housekeeping stuff. It's not that much into Waji already. The next thing that I like to do whenever I do projects like that, where I have to call some command line tools with some nice attributes and arguments and so on, is I love to use a tool which is called Just. I don't know if you know it already. If you haven't, stay tuned. Just is like make, but in a modern way, if you would like to put it that way. And let me show you how you use it. I'm going to create a Just file. This is my Just file, and I have prepared this Just file. Let me put it here. First thing, I am reading the .env file to get all the environment variables for all my commands, and then I can define commands. Here you see it, run native and build, and then you can just enter some shell commands like that. So here you see I created a run native and a build script. So now I can say just build level 1, and it will build everything for me. And I can say just run native level 1, and it will run cargo run for me. And here, down here, you see the response on standard out. So I just tried my example and it worked. Granted, just for this simple cargo run and cargo build, I wouldn't need my just file, but believe me, it will come in handy later on when we have to do some more complicated CLI stuff. Yeah, but I really like to use this tool, Just File. It's linked in the repository, so if you like the tool, take a look at it. It's in my repo. Okay, we ran it. We ran it traditionally as we are used to. So now I would like to run it as a real web application with Waji. So let's create a new file, and I call it wrong folder. Sorry, I have to create it here. I will call it modules.toml. This is how it has to be called. And here I can specify the different Waji modules that I have in my application. As you can see, I'm here referencing a folder in the target folder. I have not created this WASM file yet. We will need to compile our code with the target WASM32 WASI. We will do that in a second. But this config here tells Waji that in this WASM file, I have my gateway interface, and it should listen to this route. So when I run the Waji server, it will handle all incoming HTTP requests on this route. It will spin up my application, take what I print on standard out, and return that via an HTTP response. So let's try that. For that, we will add a little bit of magic to our Just file, and I will walk you through that one, okay? So let me show you what I do here now. First, build is still the same, but this time I add an optional target. And you see, when I call just run, it will build my sample code with this target. So I will compile my Rust code into WebAssembly. And then I will not call cargo run, but I will call the Waji server. I will tell it the configuration is stored here in modules.toml, and I can also specify a log directory if I want to gather some logs. If I screw up, I might need these logs. We will see. Another thing that I like very much is combining that one with watch.exec, another beautiful tool from the Rust universe. Watch.exec watches for changes in files with the extension rs. And in this case, I'm watching for changes in RS files in the sample that I'm just running. And when something changes, it calls just run. Down here, you see the run, and it will recompile everything and restart my Waji handler. So that feels really nice, as I'm used to do it as a web developer. I just type in some code, I put the hands away from the keyboard. The Rust compiler will compile everything to WASM. It will restart the Voji web server, and I can immediately hit refresh in my browser. So this is the kind of workload that I want to build here. Okay, so first let's run it and then let's watch it. Okay, so let's clean up here and say just run level 1. This will now run in the Voji web server, as you can see it here. And then let me bring up a browser window. Here's a browser window, and I will call the URL. I simply have to copy it here, and here it is. And as you can see it, this is exactly what we want to have. See, this is Pong. So if I show you, this is exactly what I'm printing here. So with just a few lines of code, I was able to build a web server. And of course, now we can do a little bit more web-like development. If we say just watch level 1, I can move it this one and put this one here on the left-hand side and the browser here on the right-hand side, and I can rerun it. It still says Pong, and then let's change it Pongong, something like this. And if I do nothing, you see the browser is the server is automatically reloaded. I can reload it here and everything works as expected. Let's put it back. It will rebuild everything. I can refresh it. Everything's fine. And don't worry, if you are a web developer like me, I would even complain that I have to press reload here in the browser. Wouldn't it be possible to magically link up my Rust code through some kind of browser synchronization mechanism so that everything is reloaded on all my test devices? That is possible, and I will show you that in, I think, level 2, something like this. Okay, so you see, we have some beautiful thing going on. We already built a server, and the only thing that we need to do is to print something and stand it out and use a little bit of Voji and compile it to WebAssembly. That was level 1. Now, I would go to level 1 with a little bit different flavor. Let's put it that way. Let me surprise you. First, let's pump up our just file, and you might already recognize what I do here. So what I've prepared for this talk is I've created a Docker registry. In this case, it's the Azure Docker registry. So it's a Docker registry created in the Microsoft Azure cloud. It's a standard conform registry, and I could use it to push Docker image containers there, Docker container images there. So just a regular container registry. But now, today, I would like to try to put WebAssembly there and use the Voji web server to directly pull WebAssembly modules, HTTP handler, pull it from the container registry onto my machine and run it as part of my local Voji server. This is what I would like to try. Okay? Well, first, I want to take what I've compiled before and show you that we can really push it to the container registry. And for that, I'm going to use a tool which is called wasm2oci. I linked it in my GitHub repository. It's essentially a small little program that is capable of pushing WebAssembly modules to an OCI container registry. So let's say just push level 1. This will take my level 1 WASM and push it out to the registry. And here you are. You see, it's now stored in my Azure Container Registry out in the cloud. And now I can go on and go in my modules toml file and add a second module here. And you see, this module will listen on a different route, but I'm not referencing a locally compiled WASM file here, but I'm referencing an OCI and a container registry so that the Voji will pull down the container, in this case, the WebAssembly module, and run it from this WebAssembly module, which I got from Azure. See, that is the idea. So let's try exactly that. Just run level 1. Takes a little bit longer because it's now pulling down the WebAssembly module, and that looks good. And let me show you that this stuff really works. I will now get my browser here again. Let's put it here. Let's put the URL, and you see, It's Pong. See it? Here, ping OCI. Here, ping OCI. This is exactly what I wanted to show you. So isn't that beautiful? I think that puts the statement from Solomon Hykes into perspective. I now work with the WebAssembly module built without any referenced libraries. I pushed it into a container registry and I pulled it from the container registry. Everything is running inside a sandbox. I cannot access any files or, I don't know, get some HTTP requests to other servers. It's running inside of this sandbox, and we now have a similar thing as we have in a container, but with much less overhead, because the web server is running outside. It's running outside of it's the Vagi server. We just run this little bit of code in order to get Pong out of it. Okay, that was level 1 with OCI, and I hope it's okay for you if I comment that one out, because if I leave it in, we always have to wait a tiny little bit so that Wagi will pull down the WASM module before it runs our code, and I don't want to wait for that long. Take a breathe in, breathe out, because we are reaching level 2. Level 2 is a little bit more code, and I don't want to bore you by looking at me typing some code, so I will just copy in the Rust code and simply walk you through it. It's really, really simple. It just puts out some things from the command line arguments. These are the command line arguments. It prints out some variables, environment variables. You will see what we will have in the environment variables, and it will print out what it can find in standard in. This is what I'm doing here. So I'm just reading in 3 simple things: the command line argument, the environment variables, and standard in. And we will see how Wagi is using exactly these mechanisms to pass in the payload of the incoming HTTP request. Now, this was the code. Of course, I have to add this thing to my workspace so that Rust knows that there is a level 2 application here. And additionally, of course, I have to define another route. So here you see the level 2 route is exactly what I'm going to target now. So let's give that a try and say just run level 2. This will again compile everything. It's blazingly fast because we are not using any libraries here, and that's it. And with that, we should give it a try. So let me bring up another browser here. Here is my browser. Make it a little bit smaller and fire up level 2. And this is exactly what you see here. Well, let's move it a little bit up. Oops, sorry. Let's move it a little bit up. And as you can see here, the command line arguments are first the path, and I can specify foo equals bar, also some query string parameters. So we will get through command line arguments the path and the query string parameters. All the different HTTP request headers, we will get them through the environment variables. Please note that we don't have access to all the environment variables on the machine. We just have access to those environment variables which are passed on by Vagi to us. So we can see all the different headers. I'm pretty sure you will recognize them if you take a look. Standard in down there is currently empty, but it doesn't need to be empty. Let me show you what standard in will look like when I copy in a small helper file. This helper file is using a plugin in Visual Studio Code. It's called REST Client. And with that, I can directly issue requests here from Visual Studio Code. And this is the thing that I want to draw your attention to, because this is now sending an HTTP post request to our level 2 sample. And this time I'm passing in some payload, an HTTP body. So send this one. And you see, we still have the arguments. If I scroll down a little bit, we see that the request method is now post. I see still the query string. And here, through standard in, I get the payload of the HTTP request. So still, I don't need any library for that. It's just interpreting the command line arguments, the environment variables, and the standard in. And that's it. That's pretty amazing, don't you think? I definitely think so. So this was my sample 2, where you have learned how to use the environment variables, the program arguments, and the HTTP body. So good. Breathe in, breathe out, and make ready for level 3. In level 3, I would like to make the sample a little bit more interesting. Let's put it that way. So let me copy in the code and then quickly walk you through the code of level 3. Now, level 3 has some libraries, as you can see it here. I'm using serde, obviously, for some JSON serialization and deserialization, and I'm using handlebars because this time I would like to generate HTML on the server side. Yes, you heard correctly. I'm going to create HTML, put it on standard out, and I don't want to hand code the HTML, but I want to use a template engine, in this case, the template language handlebars. Let me show you the source code and let me walk you through it. Now, here, first, interesting thing, we can define so-called subroutes inside a Vaji module. So we can say that we are listening on these subroutes here, inline and file, and then that we want to call the methods inline, as you can see it here. Here is inline, and the method template file, here you see it, template file, when these subroutes come in. So we will, in a second, define the route path here in the modules toml, and these are subroutes inside of this route path. Now let's quickly focus on the inline part. This, what you see here, if you are a web developer, you will probably immediately recognize this. This is the handlebar syntax. So this is a handlebar template. Here you see a loop over all the arguments. And here you see a template which will be replaced by the command line argument. And then I'm using the handlebar template engine. I register the template and I render the template to a string, and I simply print line the result of the rendering onto standard out. This should work, obviously, no problem. But the second thing with the file is even more interesting, because now I'm not using an embedded template, as you can see it here, but I'm reading some template from the file system. Because I created here a folder which is called templates, here you see a more elaborate template file. It's handlebar syntax, and if I scroll down, you again see some loops, as you can see it here. You see some replacements, the usual stuff if you are a web developer. Sorry. We are also using Bootstrap here, and additionally, please note that this will be important for the next demo. We are also referencing a local CSS file from a folder which is called static. Keep that in mind. We will have to fix that one in a second. So this is what we are doing here. We have level 3, which uses an inline template and uses a template file. Let me have a sip of water here. And then let's get going and let's try to set up this, this level 3 here, okay? So the first thing that we will need is a little bit of additional content. First, the static folder. And in the static folder, we have a very basic CSS file, but hey, bear with me, it's just a demo. I think you can imagine that this CSS file can be as complicated as you want. It's just there. We will see how we can serve these static files to the web browser. Obviously, you cannot just access the file on the disk. We need to do some magic in Vaji, but I will show you that in a second. And the second thing that we need to do is we need to again pump up our just file, as you can see it here, because now I will set an environment variable before calling, I will here set an environment variable for Vaji, and I will tell here the environment variable that template path points to templates. And if I show you the code here in level 3, here I'm reading the template path environment variable to make sure that template HBS is read from /templates. Okay, keep that in mind. Because now we need to enable our Vaji server here to handle the level 3 route from this WebAssembly, and here comes the magic. This is where we mount the local folder, this one, which points to this template folder here, and we mount it at /templates. So the WASM file can access my templates, only this folder where the templates are stored, through this volume mounting. And this is exactly what I want to have. My Rust code should have access to a single folder and not my entire disk. Okay? So I think we can give that a try. Let's see if I messed up, okay? So let's say just run level 3. Okay, yeah, I forgot one thing. I simply didn't add my level 3 to my cargo workspace. Sorry about that. Let's run it again. Oh, now Visual Studio is somehow blocking our build directory because it's checking a lot of dependencies, but this is now done and now the build starts. Everything is compiled with the target WebAssembly. We are still creating a WebAssembly file without any library except handlebars. And now we will give it a try. First, we will run the inline template. For that, I will bring up a web browser again, and I will call this one. And you see, this is exactly here this template. See, it's just an unordered list of list items, and I print all the different args, which are the path from the URL and the 2 parameters which I passed in through the query string. So the handlebar rendering already works. Pretty neat, isn't it? And then I will go to File, boom, and let's see. Oh my God, this looks way more beautiful. This is Bootstrap because I referenced inside of my template a little bit of Bootstrap to make it look nicer. So you see, the rendering of the template file worked perfectly fine. Well, nearly. It didn't work perfectly fine because if we get up the console, we will see that the server was not able to read the styles file. Well, of course it can't. This is referencing /static/styles. But Waji does not serve static files yet. We didn't write any code for that. What we could do is we could go into our main RS and add some additional code, maybe an additional subroute here for static, and then write our own code to serve files. But it turns out, if you think closely about serving static files, it isn't as trivial as you might think it is, because you have to deal with caching and all that stuff. Wouldn't it be nice if we would have some kind of, I don't know, ready-made static file web server which we could magically plug in? And it turns out there is one. There is one, and this is exactly the next demo that I'm going to do. Let me stop that one here again, and I will not include that one on a Rust level, but I'm going to get one, and the link is already in GitHub. I will get one in the form of a WASM module. I'm using a WASM file server for Waji, which was written in a programming language called Grain. I'm not an expert on Grain. To be honest, I didn't know that it exists until I took a look at this example. It's pretty amazing, and you can take a look at it. It's somewhat, let's say, WASM native. It's really interesting, but to be honest, I don't really care. It's like working with a container, right? I'm not caring about how this WebAssembly file was created. It is just there, just like a container is. And now I would like to use this file server together with my own Rust code, which I compiled to WebAssembly. So we need to enhance our modules file here, and I have prepared this one. See, I am adding another module which will serve all the subroutes of static, and it will take all the files inside of the static folder. Here it is, and I mount that one to exactly that folder. And guess what? Here I have my styles.css. So now it should be possible that my website loads the styles.css through the Grain file server, which is another Waji module just working side by side with my own WebAssembly module that I've written in Rust. Let's give that a try, right? Just run level 3. And did I already close this one? Oh, here is still one. So let's take this one. So level 3, here it is. Here I have the link template from file. And now let me prove that it really works by going here, reload everything, and see here, styles.css 200. Everything works as expected. I can click on that and you see my WebAssembly file server written in grain now working side by side with my Rust code using handlebars to create this awesome output. And now you can imagine that you can easily create more elaborate application, doing some maybe serving of a single page app, maybe from Angular, React, Svelte, or whatever you use, put it here in the static folder, and then write your dynamic code in WebAssembly with Waji and use exactly this combination. This could be a possibility for you. Okay? Now, it's getting more and more interesting. We are generating HTML, and as a web developer, I would like to go one step further. I mentioned that already. What I would like to have is I would like to have a possibility to change a little bit of Rust code here, and magically all the browsers should refresh. And if I go into my template and change a little bit of the handlebar syntax here, the browser should magically refresh. It turns out that this is pretty simple to achieve. And let me show you how we can do that. I prepared 2 files. Here it is. I will copy them into our folder. Here they are. If you are a web developer, you know package.json. It's essentially the package manager of JavaScript. And here I'm loading in a JavaScript module, which is pretty wide known. If you are not a web developer and you're just focusing on Rust, let me tell you, this thing is really cool. It's called browser sync, and it does exactly what it says. It syncs browser whenever local file change. So let's get browser sync by calling npm install. It will pull down browser sync from npm, install it locally in the node modules folder. This is like cargo, but in the JavaScript way. Now this module is stored here. Can close it. And I also create a config file where I tell the system that it should watch all WASM files in my folder. It should watch all handlebar syntax files, and it should watch all the CSS files. And with that, I can get the web development experience that I would like to have. Let me show you what I mean with that. First, let's run the server part, the compiler, and the Waji web server with just watch level 3. See, the just files are really convenient, aren't they? So now we have our server running on port 3000. Let's spin up another shell here and say just serve. Now just serve, if I show you that one, it runs browser sync, as you can see it here, with this specification. See? And this opened automatically here, a nice little browser window, and let's put that one side by side. Okay, and let's go to /level 3. And as you can see, it still works just as expected, but now we are not running on port 3000, but we are accessing the browser sync system, which acts as a reverse proxy to our Waji. So now I can go to template from file. As you can see, it works, but up here there was quickly a note, browser sync connected. So let me show you what we can do with that by opening up the main.rs and the template handle file. Let's go to main.rs, for instance, here, and let's first go to the inline template. You see it here? And if I go to the inline template and I change a little bit of code, take my hand from the keyboard and Emogods are smiling, and here you see everything was refreshed automatically. And browser sync does a lot of magic for you. If you have multiple devices, maybe an iPad, maybe an Android tablet that you use to check your mobile website, or maybe you have multiple different browsers, Safari and Chrome, and check cross-browser compatibility. Browser sync will update everything if you change your Rust code. Isn't that beautiful? Let's remove the exclamation marks again, and it works perfectly fine. Here it is. Let's go to the template file, and I will show you exactly the same here. Maybe let's add some exclamation marks here too, and it will hopefully update automatically without me doing anything, and remove it again. And you see, that is web development as I'm used to do it. But now with Rust and Handlebar and WebAssembly without any containers. So I think this is pretty neat. I love that when I got that running, and it's simply a pretty simple combination of small tools. This Just and Watch Exec and Handlebar and Browser Sync. And if you want to dive deeper into the code, you can take a look at it on my GitHub repository. Okay, nice. Last one. Breathe in, breathe out. Level 4. I wanted to take it one level further, and I didn't just want to access files, but I wanted to call a downstream service. So my Rust application should not just read a file, but it should get data from a different server. And nowadays, any web development presentation needs to do something with a very popular word puzzle, which is called Wordle, and I'm pretty sure that many of you are going to do. And now a very important warning, disclaimer. This will be I can spoil your surprise if you haven't done your daily Wordle. So I will now write in Rust a Wordle solver. I don't want to call it a Wordle hacker, but it kind of is, that lets you solve any Wordle puzzle from now until the next, I don't know how many years, with exactly that code. So you will be a Wordle magician with the help of Waggy and the code that I will show you in a second. But if you haven't done today's Wordle, maybe you get your phone out now and do it immediately, because you will see the result of today's Wordle in a few minutes. Let's see. Or you might also just close your eyes before I do the demo, okay? So let's take level 4. Here it is. And let me quickly walk you through the code. First, I want to say a big, big thank you to Blaumeister, Elvin. Elvin is a young coder from our Coder Dojo. He is awesome when it comes to coding. He loves Rust, he loves TypeScript, he loves JavaScript, and he has come up with this basic algorithm. And I simply took it. He wrote it in TypeScript. I simply took it and translated it to Rust. So I didn't come up with the algorithm. That is definitely kudos to Elvin, who created this algorithm. Thank you very much. Greetings to Elvin if you are watching this. Okay. So what I do here is, let me scroll down here. I am getting some parameters from the query string. For that, I have written a small little macro, which just takes all the arguments, look for the argument with a certain prefix. Here you see the prefix, and get the value. Very simple. I parse it because it's just an integer value, and I return 400 if the argument is not given. Very, very simple. Then I go to the New York Times. I do an HTTP request to nytimes.com. Keep that in mind. We will need to enable that because, as Stefan told you, WASM is running inside the sandbox and cannot just call out to any URL. We have to enable that. So we will call the web server of the New York Times and fetch the HTML code. Then I will do some regex magic to find out the JavaScript bundle. This is a bundle and has a hash code in it, so we need to find the hash code. And then I'm going to download the JavaScript file from New York Times. Last but not least, Elvin took the time to go through the Wordle code and found out with which regular expression we can find all the words of all the solutions inside of Wordle, inside of this JavaScript file. So we are here looking for the words for all the solutions inside the JavaScript file. It turns out that Wordle is just client-side scripting, and all the solutions for the upcoming days and the days before are inside the JavaScript. And last but not least, we do a little bit of calculation magic here. Again, kudos to Elvin, who came up with this formula to calculate the offset inside of the words array, which we got from JavaScript. And with that, we can get the result of every Wordle in the past and in the future, at least until the New York Times will change the JavaScript code. I don't know if that ever will happen, but for now, I hope they didn't do it in the last hour or something. Let's see whether that works. Okay, this is essentially what this code does. If you take a look, I'm using here a crate which is called WASI Experimental HTTP. I have to do that because the network support in WASI and WASM is not stable yet. It's experimental, and therefore I have to use this crate. If you want to learn more about this crate, a link to the crate and the description is in my GitHub repository. I will show you that at the end of my talk. Again, we mentioned it before. Now let's enable everything. So let's copy this one out here. See? And as you can see here, I have my module, which is no surprises here, just my WebAssembly. And here is the magic, allowed host. Here I'm allowing my WebAssembly sandbox to access the New York Times, but no other URL. If I try to access any other host, the WASI, the WebAssembly runtime, would block this call, and I would not be able to get or post anything to them or get from them. And therefore, this is the important thing. This is why I created this example, because this is exactly what I wanted to show you. Do you want to see whether it works? Well, I want, and let's give it a try, okay? So let's just run, but this time, or just watch level 4. This will compile everything. Oops. Of course, again, I forgot to add the project to my workspace. I'm sorry for that. So let's again do just watch. We have to wait a second until Visual Studio Code has finished looking through my code. Now it's compiling. Should be done in a second. Here we are. Web server is running. And I stopped my my browser sync. So let's run browser sync again to auto refresh our browsers. And with that, we should get, here it is, a browser window. Now, let's put that one on the right-hand side and my code on the left-hand side. I will go to /static wordle.html. See, this is a, I'm blunt here and saying this is a single page app. Essentially, it's just an HTML file with a little bit of JavaScript in it, you see? So what I do here, I'm populating these 3 fields, year, month, and day. And then I can do a form to my Rust code, which will then try to solve Wordle using the algorithm that I showed you before. So let's begin by trying it for yesterday, okay, for the 23rd. So this shouldn't be a spoiler for anybody. Let's submit it. And now, if I'm lucky, oh my God, it worked. It really worked. We went out to the New York Times. We got the HTML. We found out their JavaScript bundle ID. We went to the New York Times again, got the JavaScript, parsed out the words, calculated the word index, and we came up that yesterday the solution was purge. And believe me, that is the correct solution. I tried it yesterday. And now, if you want to do Wordle for today, please close your eyes. If you have done it already, or if you don't care, just take a look. We will do it for today. Here we are. 24th, it's chest. See? Chest. So let's try that one. Crossing fingers. C-H-E-S-T. Enter. And yeah, we are geniuses. We definitely are. We are geniuses because we now created in WebAssembly with WASI a server-side logic inside a WebAssembly sandbox. And we allowed our WebAssembly code to reach out to exactly that URL. By the way, thank you to New York Times for this beautiful puzzle here. I love it. It's really nice to do, and it's nearly a daily breakfast puzzle. I really like it. Thank you very much for it. So, ladies and gentlemen, that's essentially all that I wanted to show you. If you liked this presentation and if you would like to go through it again, here is the GitHub repo. And you see, this is my storybook. So if I scroll down, you see all the steps that I did. I scripted them here with the links and all the stuff. So if you want to redo my demo and try it on your own computer, feel free to do so. I hope you liked what I was showing you. And with that, I have to find the correct window. And I would like to give back to Stefan. Maybe Stefan is here and can have a quick
Hi.
hand. Stefan, how did you like my demos?
Oh, I enjoyed it. I love Wordle. So the moment you said you're going to spoil today's solution, I was just hopping onto Wordle and was solving it. And my starter words, I have 2 starter words, party and house. Party house, brought me 4 or 5 letters, so it was easy done in the third one. So it was cool. I enjoyed it. We even got some questions. So Thomas was asking if there are options to set the limit on the size of the request headers or the limit of the size of the request body. And while you were presenting, I looked it up, and I wasn't able to find anything. So Waji follows the RFC 3875, which is the CG11 specification. And I looked that one up, and I was looking if it was specified there. It wasn't specified there as well. Some old Perl CGI servers had a limit of 1 megabyte, but that was the 90s, but you were able to configure it. This configuration does not exist in Waji right now. So not in the code, nor in some feature to come. It might be though. So yeah, that's it.
I didn't know the answer, so thank you for looking it up. And I just saw, let me give another shout out to Elvin. Hey Elvin, thank you. Thank you for providing the inspiration and a little bit of code for this demonstration. I really enjoyed doing it, and I just read you didn't come up with the formula. Yes, you're right. You found it in the code, although, and you are perfectly right. I thought I shouldn't say the result because that would be a spoiler, and I messed it up and I said it, and I'm very sorry if I spoiled your Wordle for today. So yeah, I'm sorry for that. Still, I hope you enjoyed the presentation. Okay,
Stefan, yeah, it was lovely.
We had 2 very different talks today. One was down to the metal kernel and pointers and pinning and unsafe, and one was really application development with WebAssembly and so on. And yeah, I had a blast. I hope
it was fun. It was a fun meetup. So I want to thank my family for giving me a free evening today because I enjoyed being there a lot. Enjoyed the demos. I enjoyed Miguel and Wetson. So this was fun. We were looking forward to this talk for a long time. So I don't know when you reached out to Miguel for the first time. I guess it was sometime last year. So really happy that this finally happened. And since you are showing the banner, so for everyone who was in the stream today, and there were a lot of new people, which is fantastic. So great that you join us. If you want to speak at Rust-Linz for whatever topics, you've seen we had this huge range now of topics. Rust is a versatile language. There's lots of stuff going on. If you want to speak, show us your idea. If you are not sure if the idea is good, talk to us. We can work on it. We can give you feedback. I'm pretty sure it is good for a talk because, hey, if you've experienced something, share it with us. And yeah, I hope you tune in next time as well.
Absolutely. We will see each other in approximately a month. This time it was exactly a month. We have the 24th of February and now we have the 24th of March. And it will be sometimes, I think, in the second half of April. We will announce the day on meetup.com. So subscribe or take a look at the rustlinz.at. We will also announce the next meetup there.
Exactly. And I guess we have 2 speakers already lined up who we're going to finalize. It's going to be interesting.
Yes,
lots of cool new stuff.
Yeah, definitely. We nearly had one of them for this month, but it didn't work out because of date constraints. But we are looking forward to some interesting guest speakers in the upcoming months, definitely.
Absolutely. Good.
Okay, so have a nice evening. Enjoy another month with Rust and be back in a month.
Bye-bye.
Bye.